Assalamualaikum warahmatullahi wabarakatuh. Hello, welcome back to my YouTube channel. Today, I want to discuss something related to physics. When I was a child, I really wanted to know why planes can fly, and this time, I will talk about it. For those who don't know me, I will introduce myself. My name is Ulfa Andini Tian Pamestri. I was born on the 14th of June 2002. Now, I live in a village in Sidoarjo, precisely in Wonoayu. I studied at the IAIN Tulungagung campus majoring in physics. The reason I took physics major is because I was inspired by my two teachers. They both are extraordinary, very good physics teachers, so I hope that I can become a teacher like them. Okay, we start from the beginning of the development of the aircraft. Airplanes are one of the most popular means of transportation because planes are considered to be able to shorten travel time. But have you ever thought how planes can fly? The origin of the concept of flight is an imitation of a bird is a flying by flapping its wings. Historical that Wilbur Wright and Orville Wright were the creators of the first engined aircraft. At the time they wanted to release the imagination of humans who wanted to be able to fly like birds. This desire was triggered by a sketch of helicopter that Leonardo da Vinci made in a year of 1452. Name Fit Area. Under history records, various experiments with the concept of larger than air, their monoplane brothers from France in general have success in building the first hot air balloon, and the first person to fly with a hot air balloon was a physics Jean-François Pilatre, and the first design concept that used a fixed wing to lift and other surface to control and the propulsion system was Sir George Cayley, and who was later called a glider. Then, by continuing the concept from Sir George Cayley, Otto Lilienthal redeveloped the concept based on the principles of fluid flow, which he learned while studying at the Department of Mechanical Engineering at the Berlin Technical Academy. Orville and Wilbur Wright, who were the most popular people in the history of aviation after they learned the concept of Otto Lilienthal, they then built a glider until finally in 9002 the first aircraft with 3-axis control was built in, and it became the first history of flight with a motorized control system. Next, there are several different forces acting on objects flying in the air. There's aerodynamic force, include lift, thrust, weight, and air drag. These forces influence the flying profile of objects. In the air, from birds can fly naturally to even the largest aircraft. This is where the challenge is because you have to fight gravity. So, physicists like Isaac Newton, Bernoulli, and Coanda, the three of them work together to answer this challenge. Newton's Law 3. Isaac Newton, who is famous for his three equations of motion, contributed Newton's third law of action-reaction. Benjamin Crowell, in this book Newtonian Physics, says that when object A exerts a force on object B must also exert a force on object A. The two forces are equal in magnitude and in opposite direction, and it can be written briefly with a formula like the following: Fa on B equal minus Fb on A. This law is then applied to the study of aerodynamics in airplane wings, airfoils. The wing of airplanes, the wings of an airplane is the most important part of generating lift. Airflow occurs above and below the aircraft wings. The air particles hit the underside of the plane's wings. The particles that hit this are then reflected downward or towards the ground. With air raining down on the ground is a force of action, and then the ground which receives this action force must immediately give a reaction force which is equal to the force of action but in the opposite direction. An example of application of the Newton's law 3 is a moment hand push the table. When your palm pushes the end of a table, the shape of the palms will change. This proves that there is an action-reaction for force and the table and hands. The thrust of the hands exerts an action force on the table which causes the table to move, while the table exerts a reaction force on the palm, causing the palm to change its texture. Next, Coanda effect and Bernoulli law for the top of the wing. There is another process which also produces action according to Coanda. Air passing through a curved surface will flow along that surface, or known as the Coanda effect. This is evidenced when we put a burning candle in front of a bottle. When the candle is blown from the back of the bottle, it is strange that the candle in front of the bottle will die. According to Coanda, this is because the air we blow flows along the curved surface of the bottle and the blow candle flame through it. This is how the air passing through the top of the wing is like the air moving along the bottle. This air will flow along the top surface of the wing until it reaches the underside of the wing. At the lower end of the wing, the air particles gather and accumulate until they are overweight and fall off, which is called a downwash. This downwash is also a component of the forces of action. The ground which receives this action force must directly exert a reaction force equal to the magnitude of the action but in the opposite direction. Because the action force is toward the ground or downward, it means that the reaction force is upward. This reaction force provides lift, which can lift the planes and defeat the gravity. Due to the gravitational pull of the Earth, another source of lift is the difference in air pressure on the upper surface and the underside of the wings, which is where Bernoulli's law applies. For incompressible flow, where rho equal constant, the equation that occurs is. The above equations is called the Bernoulli equation, where P1 is relative to V1 and P2 is relative to V2 along the airfoil surface. When the air will flow over the top of the wing, the pressure is P1. When the air passes under the wing, the air pressure in that area is P2. The velocity of the fluid on the upper surface of the airfoil is bigger when compared to the velocity on the floor and the lower surface of the fluid. This causes the pressure of the upper surface of the airfoil to be lower than the pressure on the lower surface of the airfoil, so that it produces light which is used to lift the aircraft. This correlation is in accordance with Bernoulli's law. The drag coefficient is a function of the dimensionless parameter used to measure the resistance of an object in the environment, fluids such as air and water. In use, the smaller the coefficient drag to object, the smaller the drag on an object, and more aerodynamic efficiency. The drag coefficient can be found by using the following equation. The lift coefficient is a function of the dimensionless parameter that shows the amount of lift acting on an object following by the fluid. The lift coefficient is greatly influenced by the shapes of the objects. The lift coefficient can be found using the following equation. In general, the slightest increase in the angle of attack results in an increase in airfoil angularity, but when it reaches a certain angle, the airfoil will lose its lifting capacity. This angle is called the stall angle or critical angle of attack on the airfoil. The critical angle of attack is the size of the angle of attack where the resulting lift reaches the maximum. Above that angle, the lift will decrease while the air resistance drag will increase rapidly. This can happen because the turbulent flow gets bigger compared to the airflow around the wings at small angles of attack, which is what can occur when flying straight and horizontally and at larger angles of attack. When the angle of attack is enlarged, the lift generated by the airfoil will increase. Okay, that's the explanation for me. I'm sorry if I spoke wrongly or was not fluent. If you don't understand, I will provide a PowerPoint link in the description. Okay, thank you and see you next video. Bye bye.